position is, route is there, X, okay, departure wherever. Okay, and now you see our route and the departure. What we are going
zoom in
to
there.
fly. Yeah, yeah, exactly. First you can change the mode. Now it's centered on the plane, and now it can be centered on certain waypoints. Just leave it there, and you can zoom in or out in this case. Yeah. And if we look at the route now, after takeoff, we climb to 3,000 feet, and as soon as we have reached the 3,000 feet, a left turn towards our first waypoint, Limra, and then it goes this kind of zigzag course down to our arrival airport, which is there. And how we get from there to there, that's something we'll have a look at in the flight, because then I can give you a detailed explanation how this is done. Okay. Next thing, performance initialization. So the plane needs to know how heavy am I, how high am I going to fly, and so on and so forth.
But we say that already here.
Yeah, that's correct, but that's not that's not something the plane can work with. That's just for the cabin pressurization. The plane doesn't really know that this is our altitude. That's the navigation critical input. Yeah, it's correct. We told it there, but that's just for the pressurization controller. It doesn't have any navigational impact. We have to do this here. So, first of all, I punch in the weight. 58.4 tons. 58.4.
That's including passengers?
That's including passengers, but without fuel. Yeah? There's a so-called zero fuel weight. You have the weight with all the cargo, but without fuel. 58.4 plus 4.2 is 62.6 tons. Okay, that's the gross weight. That's the zero fuel weight.
What is that noise?
It's static from the lamp. Yeah. Okay. Fuel reserves.
That's
2.2.
Okay.
That's the speed, and you can punch in now the altitude. You can punch it in here. 300. Just type in 300.
Has to select here first?
No, you don't have to select it first. Also, it's the upper one. Just punch it in, 300. No, that was too much. Just you have the clear button, because there it's okay. And top right. Exactly. And now the plane knows everything it needs to know. How fast, how high, how heavy am I? Okay.
So you didn't select all the control points, or you
no, because I loaded the complete route into the system. You can punch it in manually, of course, but normally it's like this: that the company prepares flight plans, uploads them, and the crew just downloads them in the system. Several airlines need the pilots to do it manually. Ryanair, for example, they are not allowed to load any routes. They have to manually.
Why?
Yeah, it has something to do with fail-safe. You have to check it anyway, so it wouldn't make too much of a difference. But they want their pilots to really manually input the flight plan. Okay. N1 limit. Next page. That's the engine limitation. Because normally you would never start with or take off with 100% power. You would actually use as less power as possible. Any ideas why that could be?
To save.
Save, yeah. Save what?
Save power in case of something is doing something else.
Well, but you could go at 100% anyways, because then you wouldn't have to save anything. You could go 100% and you would never have a problem, because you would always have 100% of power. You could always go full speed. Or full power. It has to do something with saving. First of all, of course, fuel. Second of all, engine life. Yeah. It's the same reason why you wouldn't go with your car and always be in first or second gear, because it would stress the engine. And this plane is about $80 million or euros, of which about 25% is only the cost of the engine. So you would like to extend the life as long as possible. And there's a relatively complex calculation behind it. It depends on runway length, it depends on temperature, it depends on air pressure, stuff like that. Then it comes up with a figure. In our case, it's 93.4% of the max N1.
Okay.
Cockpit to ground. I need the center of gravity, please.
Center of gravity is 16.8.
Center of gravity, the dispatcher or the loadmaster gives us the center of gravity, which tells us where the center of gravity is, so that the plane wouldn't be too much tail or nose heavy. Okay.
Is that depending on the passenger's load?
Yeah, depending
Or
on that, they average it on about 70 kilograms, but that's the reason why you are not allowed to change seats as soon as everything is done, because it would, under certain circumstances, dramatically affect how the plane's handling. Yeah? Okay, and now we have the last input, the V-speeds. I don't know if you heard about those, what they do.
The speed of the wind?
No, it's actually 3 critical speeds for takeoff. V1 is the decision speed until we reach, after reaching V1, in our case 135 knots, we cannot abort the takeoff. Should we have an engine fire at 135, we would still have to take off and solve the problem in the air. Okay. 135, you have to commit to the takeoff. Okay. 136 is the speed where we rotate, so pulling up the nose, and 145 is the actual speed, the actual flying speed. Okay, at which the speed the plane needs to stay airborne. Okay. 145. Just dial it in here, the speed window. Then we also have, we need our takeoff heading, which is to the west, 263 degrees.
To the west? The current one.
Exactly. We're looking facing in the wrong direction, so we have to go in the other. And we'll punch out. That's the altitude. 263.
Oh, how was it at the before? To what?
263. 263. Okay. Because should we have an engine failure, Schatz, ich habe mich nur vorverwirrt, gell? Tschüss. Should we have an engine failure, we wouldn't continue on our track, of course, we would continue on the runway heading, okay? And for this scenario, we would only have to press this button and the plane would stay on the runway heading instead of just doing the turn here. Okay, and now we can actually...
Wait, we're going in that direction right now?
We're going in this direction, so we have to turn out, go down there, on the lower, on the down end of the runway, we turn around, and then we go in this direction.
Okay.
Exactly. Okay, so now we are still on ground power. We need to produce our own electricity now. That's the auxiliary power unit. That's
we
a
have
little
generators from the airport. Strong controllers.
At the moment, we still have the generator, but we can't take that with us, of course. So we need to have an own electricity source. That's the auxiliary power unit. It's a small turbine in the back of the airplane in this cone. Switch that on. Exactly. It takes about a minute to spool up, and in this time, during this time, we go through the first checklist. Okay. Just read this, and I quit.
Oxygen tested.
Oxygen tested 100%. Yeah. Okay.
Instrument transfer switches.
Normal. Those are these.
Window heat.
We know this one exactly. On.
Preservation mode selector.
Auto.
Fly instruments.
We check if our instruments show the same values. Heading at the moment 03, 03. Correct. Altimeters are still not set correctly because the altimeter depends on the correct air pressure. Linz is at about 980 feet. Yeah. So the air pressure should be.
You change it and you change it here.
You can change it here slowly to 1018 hectopascals. Okay, 1014. It's a little finicky. 1018, and now we have the correct.
How much?
1018. 1018. And now we have the correct pressure, and also here on the standby instrument. So both instruments show the same values. Heading 03 and all 3 altimeters show the same values. So that's checked.
This is manual?
This is standby. The standby. Should those fail, you still have a standby altimeter. Okay.
Heading altimeter.
Genau. Checked.
Parking brake
is set.
Engine start level.
Cut off. Pre-flight checklist complete. Put it in this little space here. And then we call for our clearance delivery, okay?
Delivery?
Yeah, because the flight plan has to be cleared with the respective controller, because something could have changed. The runway, the active runway could have changed. The departure route could have changed, and we need to verify that. Linz Tower, Servus, Synthetic 737, stand 31, ready IFR clearance to Rijeka.
Synthetic737, Linz Tower, Servus. You are cleared to Rijeka via Lima 1 Whiskey departure, runway 26. Squawk is 4601, flight level 100.
Cleared Rijeka via the Limra 1 Whiskey departure, runway 26, squawk 4601, flight level 100.
Synthetic737, repack is correct. The engine start approved, call me for taxi.
Engine start approved, calling back for taxi. Okay, so he cleared us via the departure route. We can use this one, yeah, the one. Runway 26, of course. Squawk, that's the code. The air traffic controller.
This is the only runway that we
that's the, exactly, you see, 26. That's this one, okay? And the altitude flight level of 100. You don't count thousands of feet, but flight levels, and it's the correct value for the first step.
Okay.
We are not allowed to go higher than 100 at the moment. We'll receive our step ups as we go. Yeah? Okay, good. Then we start our engines. It goes like this. Ignition, right and left. Yeah. First of all, we have to activate the auxiliary power unit so that we can disconnect the ground power. Push those for two. Yeah. Okay, and now we have our own electricity. You can disconnect this one. It still stays illuminated because the cable is still connected. Okay. Cockpit to ground. Disconnect ground power, please. Okay, and now we start the engines. We start with the right engine.
Why?
It's actually how the system is wired and how the generators. It actually doesn't matter, but the standard procedure is to start the right one. Push it, turn it to ground. Then we wait a minute. Then we wait for 20%, and after that you just pull it back. That's the fuel lever, and just move it up here, and then we wait. Okay.
Okay.
Start engine number 2. Push left.
This is number 2 on the right.
Left.
Ground.
Okay.
Okay. Wait 20.
My bad. Wait a minute. We need air pressure in order to start the engines. Air pressure provided from the auxiliary power unit. So, okay, the pressure valve is open, and now you can start. You can do it again. There it is. Okay.
I get lost in.
Yeah, of course, it's a lot. And at 20%, just.
That's the engine starting.
Exactly.
How much time do we have to start taxiing after we say that we're clear?
It's okay. At little airports or small airports like Linz, it's not a problem. At really, really busy airports, you would have a departure slot which you would have to hit. Otherwise, you would have to wait another. Because the departures are timed in a very busy way, so you really would have to get going within 10 or 15 minutes at the least.
This is the brake, no?
Exactly, yeah. Okay, and at about 17%, this one flicks back to off, and then you can start number 1. Start a cutout, start engine number 1.
We went
exactly, that's the correct one.
For this we need again the pump?
Which pump?
We tried before this one, and something was missing here. What was that?
Something was... No, that's for both engines. You can see the diagram. The air pressure can go into this engine, and it can also go all the way over there in this engine. So it supplies both engines with air pressure. So we don't have to do it twice. Okay, start number 1. Exactly.
And on 20 we give more fuel.
At 20.
Yeah.
You can see the exhaust gas temperature rising. You can see the fan rising, and also the fuel flow, oil pressure rising, oil temperature rising, of course, oil quantity. That's all in this system. Now you see the EGT rising.
EGT?
Exhaust gas temperature. It's a critical value. And there's a rule of thumb. If there was a good engine start, you want to have 2 here, you want to see a 4 here, and you want to see roughly 6 here. 2, 4, 6. Okay, so we wait for the engine to stabilize, which is the case. Now we let the engine generators take over the electricity production. Our pitot heat, so that our speed and altitude sensors are not freezing. I'll put the air conditioning back to on. ignition to continuous, so we have a continuous ignition spark for takeoff, and you can switch off the APU. Exactly. Flaps 5. Now
what
we
is this flaps?
The flaps, those surfaces that stick out of the engine, which have the purpose of enlarging the surface of the engine. The bigger the surface is, the slower you can fly.
The surface of the wing?
Yeah, of the wing. It's like a bird spreading its feathers. The bigger the wing is, the slower you can fly, and especially for takeoff, that's of course critical. Now we do the flight controls check, so we move the flight controls, just grab it, and go full left, please. Center. Slower, so that you can see the ailerons moving. Yeah. Center. Full right. Center. Full up. Center. Full down. Center. And the rudder pedals. Yeah, exactly. Push it slowly to the left.
To the left.
Yeah. Center. And right. Center. Okay. And that's the little steering wheel we use to taxi on the ground. Okay. It's a little weird. It's a little difficult because but that's the way it is, because it handles totally different from a car. Okay. Just you will get used to it. Linz ground synthetic 737 ready for taxi, runway 26.
Synthetic 737 taxi holding point Foxtrot, runway 26, QNH 1009. Sorry, 1019.
1019 QNH. Okay, I'll give you the new one. It has changed. Okay, good. I'll be handling the throttles at first, so that you get a little bit of feeling. We are going towards those two yellow arrows, and we are following the line in between of them to the right. Okay. I tell you when to start or when to start steering.
But we have the you pull the brake already.
I put the brake exactly. Okay. Wait a little bit, and now start going to the right slowly. Not all the way, just a little bit. Increase it, give the plane time to do it, and if it is not enough, then do a little bit more. Yeah, great, that's good. A little bit more to the right, and now hold it. Hold it until the line is ahead of you, okay? This one. Great, and now slow, yeah, a little bit more. Hold it a little longer, and then we go to the left, following the line to the runway, okay? Slowly to the left. Oh, great. That's great. Because this is the first check for me if the person flying next to me has a little bit of feeling in their fingers, because normally people are really, really confused by how this works. But I think that we should be good in your case. Okay. Hands on the throttle. This one. Okay. That's the speed on the ground. We are aiming for about 10 to 15 knots, okay? Pull back the throttle to idle. Pull it back, pull it back, pull it back.
Which just okay.
Exactly. And now we are slowly following the yellow line to the left. Okay. Yeah. Start turning. Start turning. Hold it, hold it, hold it, and hold it for as long as possible. Don't. Yeah, no, it was okay. It was actually even still too early. Okay.
Okay.
A little bit of throttle. Both. Yeah, exactly. That's enough.
737, backtrack lineup runway 26.
Backtrack lineup runway 26, synthetic 7 is a little less. Just pull it back again. On the runway and then to the left to the end of the runway.
We're going kind of fast, eh?
Yeah, it's not a problem. It's still okay. It looks faster than we actually are going. It's 22 knots. That's okay. Okay. Clear right, clear left. Okay. And then back to the end of the runway. And oh great, this was good. Stay to the left so we can take the turn at the end of the runway, okay? Great. So, da, jetzt wird's dann ernst. Könnt ihr hier sitzen, gell? Am Ernst. Okay. Okay, throttle's back. Pull it back, like this, okay. I'll do the braking. Let it roll a little bit for a little And if I tell you, then you go all the way to the right. But wait, actually go a little bit to the left so that you can swing over. That's enough, okay? And wait a minute. Wait for it. And now go right, full right, okay? And hold it, okay? Hold it, yeah. Great. Still hold it. A little more thrust. Yeah, exactly. Hold it, still hold it. We have to cross the line again. Okay, wait a minute. Let it roll. Wait a minute, wait. And now a little bit to the left.
Okay.
And now we are aligned. Okay, great. That was good actually. Shouldn't be too much of a problem. That was actually the hardest part of the whole thing, okay? So just relax. No, it's really, it's more difficult than the flying is, okay?
No, okay.
Linz Tower, Synthetic 737, runway 26, ready for departure.
Synthetic 737, winds 270 degrees, 9 knots, runway 26, cleared for takeoff.
Cleared for takeoff, runway 26, Synthetic 737. Okay, let's go through the process. First of all, you set 40%, so you move that clamp to the fore, then we wait for the engines to spool up, okay? At 40%, you hit this black button here, hands off the throttle will move automatically to the forward position. You just take your steering wheel, you just look outside the window, and you keep the plane center line with the pedals, okay? And as soon as no, you don't have to. The pedals also move the nose wheel, so it's actually enough. And the faster we get, the more airflow we have, the more effective they get. It's not a problem. You don't have to touch this, okay? And if the plane calls V1 rotate, or if I call to amplify it, you just start pulling back, okay? Until the nose goes up, and shortly after that, you concentrate on your flight director, okay? Everything's mirrored, so I can, should there be a problem, I can do that anytime. Ready?
Wait, okay,
ready?
So we put the clamp in 40%, you said?
Exactly. Just move it a little bit until the bracket goes to 4. That was too much. Back a little bit.
Okay, both engines are 40%.
Yeah, it's okay. Now push the button, the black one. Push it again. Was too much, probably. Wait a minute. So auto throttle is not armed. Okay. Wait for 40%. Yeah, push the button. Exactly. Okay, and now off we go. Lightly on the pedals, to the right a little bit. Exactly. Yeah, that's okay. Thrust set. Airspeed alive. $80 knots, cross-checked. That's good.
Oui.
Sehr gut. Speed checked, flaps 1. And mind you, be prepared for our first sharp left turn, okay? You don't have to stick always to the flight director. You can also look out a little bit. Normally people tend to don't look away from that, but you're doing fairly well, so that's not a problem. So there's the left turn. In the turn, you always have to pull the nose a little bit up because the nose wants to drop below the horizon. Okay. Too steep. Easy. Yeah, great. No, less. Yeah, exactly. And a little bit to the right. Yeah, great. Okay. No problem. That's actually quite good. Oh, but we want to go up. After takeoff checklist. Engine bleeds on, packs auto, flaps up, no light after takeoff checklist.
You have to make the checks, please, even though we are flying?
Yeah, there's always checklist, because you have to ensure that the plane is configured properly for level flight, okay?
And
you could have forgotten the landing gear, you could have forgotten the flaps.
And that's what the first official is doing?
In this case, the first officer, if you're busy flying, then the first officer would be calling the checks, exactly. Yeah. Great, that's actually good. That's really, really good.
We're in the clouds now.
Yeah. We need engine anti-ice. We're below 10 degrees and in visible moisture. I'll put the anti-ice on.
What is anti-ice?
Anti-ice, it's hot air heating the cowling of the engine, so that you won't have ice build up on the engine inlet, okay? Because you don't want that, and it can occur as low or as high as 10 degrees. If you are flying through moisture, clouds or rain, and it's less than 10 degrees outside, anti-ice is mandatory.
Okay.
But now we're leaving...
7 contact Linz radar 129 servus.
Linz radar 129 servus. Linz radar Synthetic737 passing 8000, climbing flight level 100.
Synthetic737 Linz radar identified, good day, continue flight level 190.
Continue flight level 190, so you can set the new altitude now, 19,000, okay? Yeah, great. Exactly, and you can go on flying.
So every time you're like 40% out of course, there is an alarm.
No, that was incidentally. It told us that we are close to 10,000 feet our last altitude. Okay. No, it doesn't really. The only one complaining would be the air traffic controller, but the plane doesn't really complain if you are off course. Okay.
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 What is this?
That's the standby. Those are all standby instruments that mirror the ones here. Okay.
Okay.
Should really everything go down south and you won't see anything, you would still have these three instruments.
This is the horizon. This is the altitude.
Exactly, and that's the airspeed down there. Okay.
We are approaching Limbra.
Exactly, and that's our initial cruising point. So that's where our highway actually starts. Okay. Now that was the ramp. Okay, we used to get on the highway, and now we are on the highway. The active waypoint is always
this green line.
this green tells you where you at the moment where you will reach the altitude dialed in here. So in roughly 12 miles, we will reach 19,000. Of course, the more you move it, the more this goes up and down. It's just to plan ahead and to know when you reach a certain altitude. Everything's about mentally staying ahead of the aircraft. Okay, you don't want to get in a situation where you don't know what the aircraft does, and so it bombards you with tons of infos, and you have to filter those. Okay, nose up, nose up, nose up, nose up, nose up, nose up. Yeah, exactly. Up, still up. Yeah.
What is that alarm?
That's because we are in the overspeed range now, because you nosedived a little bit. Easy. Just sit back, breathe, put it down. You don't have to do it in a certain amount of time. You don't have to win a race or so. You can do it really
calmly.
Yeah, calmly, exactly. But it's but you're doing really well. It's normally.
Synthetic737 conduct wind radar 13435.
13435 wind radar.
That's another radar.
That's now, it's still, of course, Marco, but he simulates all the different positions. Now we are away from Linz radar. We have been handed over to Wien radar.
So we talk with another controller?
Exactly, yeah. Wien radar, Synthetic737 with you, flight level 170, climbing flight level 190.
Synthetic737, Wien identified, continue final flight level 300.
Continue flight level 300, 30,000 feet. We are cleared for 30,000 feet. You can dial this in.
30,000 feet.
It's a little bit of multitasking, but it's okay, yeah. Just dial. You can move that really, really fast, exactly. Up. 30, flight level 300 set, checked. Okay.
You fly always with both engines?
Yeah, you should. Taxiing on the ground, not so much. Normally you would turn one off as soon as you land to save fuel, but you're not allowed to shut one down. Not even if you have 4 of them. It's just a redundancy.
Safety.
Okay. Gear 1 Hotel.
Where is the compass here?
That's just another compass. You have lots of. It's just mirrors this one. It's just a backup, so you wouldn't have to look to the side. Okay.
Okay. Is the air changing temperature and making us go higher and lower?
Pardon me, I didn't get that.
In flight, there are air currents and
of course, that's also a reason why you would always have to adjust for the pitch and the flight director.
Okay.
But at the moment, it's relatively calm.
This is usually done by an automatic pilot, no? Autopilot.
Yeah, of course. Now, in real life, the automatic pilot would have been flying for the past 10 minutes. As soon as you are above 400 feet, you would activate the autopilot. But it doesn't really make sense in our simulator, because you should actually practice the handling of the plane.
Yeah.
But still, at cruising altitude, we'll put on the autopilot, and then I'll show you how we plan the arrival route, so that we have done that in advance. But pretty solid flying until now, really good.
Playing with the pedals will make a big change?
No, not in cruise flight. Pedals only in the low-level regime. Yeah, you wouldn't have to touch them. Of course, if there are certain conditions like an engine out, you would of course have to use them. But normally, the plane flies coordinated turn on itself. In small planes, you would always, whenever you move the aileron, you would always have to put in a little bit of rudder. You don't have to do this with an airliner.
Okay.
Just activate the autopilot for now. Leave it. Release the pressure and now push here. Okay, great.
Something move here. What it was? This.
That's the trim. So the aircraft stays in trim. If people are moving around the aircraft or air currents hitting the aircraft, it also it has to rebalance. Okay, and with these wheels, it adjusts the angle of the elevator, the fins on the back. It adjusts it into the airflow so that the plane is not too tail heavy or too nose heavy. And normally it can happen that it constantly moves. Okay, and you would also have to more modern airplanes don't have these anymore because it's done electronically. But this is actually from the 60s, and you could actually move it by hand exactly. Should you have to. Okay, great. Let's talk for a brief moment about the approach, how this is done. Into Rijeka we have a so-called ILS approach. I don't know if you ever heard about that. An ILS approach. There are several types of approaches, actually dozen types of approaches, but it breaks down into non-precision approaches and precision approaches. An ILS approach is a so-called precision approach because an ILS is a radio signal actually, okay, That's the approach chart. Top down, okay? That's the terrain. That's our airfield, the runway. And you see this, this little
line is where
line here, exactly. That's where we can go in. It's a radio signal transmitted from the end of the runway, laterally and also vertically. It's like I always say, like a water a cone and a water slide that gets narrower and narrower the more you get down. So if you tell the plane the frequency and the course of this cone, it would actually be possible for the plane to land itself, even without any visibility. Okay, it just follows the signal, and the plane would actually be able to land itself and keep itself on the center line. That's actually pretty old technology. That's possible since the 60s. Okay, because it's all analog. You wouldn't have to have had any digitalization.
What is this we hear in another plane?
That's just for ambient noise, a little bit radio chatter, real radio chatter, to make it a little bit more interesting. Okay, and we have to tell the plane those things in order to have it fly it correctly.
Okay.
Exactly. And we have to load this approach chart into the system, because you see here, that's our airplane. We have to still punch it in order to have it. So you go to this page, departures and arrivals. There are all our departures and arrivals for every airport in Europe. Okay. We want to arrive into Rijeka, so you press arrival in Rijeka, and then I already activated the arrival route. We have to tell it the correct approach now. We are using the ILS Zulu for runway 114. ILS C runway, exactly. Activate it, execute it, and now it's in the system.
737, contact Ljubljana radar 125275.
125275. Ljubljana radar Synthetic737 with you at flight level 300.
Synthetic737, Ljubljana radar identified, expect late descent.
Expecting late descent, Synthetic737. Okay, and now we still have to tell it the frequency and the course. The nav frequency for all the different nav aids, you can put them in here. This one is before the decimal. That one's for behind. Okay, not bad. 10850 is the frequency. 50. Exactly. No, 50. 50. You can activate it by pushing the TFR, the transfer button. And now it's active. That's always standby. You can only change it on this side, and you have to activate it by pushing this button.
Okay.
That's the frequency, 1085. The course is going to be dialed in up here, 140 degrees. That's the course for it. Okay. And then there's a lot of other info.
But this will happen only when we're approaching, and we're punching it now. So
it doesn't make any sense, because it only gets in effect as soon as we hand the plane over to the radio signal.
Okay.
That's this button. As soon as the plane senses the beam, you push this button, and only then this comes into effect.
Okay.
Then you would have to have the correct heading. If you have the wrong heading here, then of course the plane doesn't know what to do, because it senses the signal but from a wrong direction. Okay. This doesn't have any effect on our current heading. Then it also tells us the so-called missed approach after go around. So should we have to abort the landing, that's the routing. What we would have to fly for another try. It also is here. Missed approach. Climb straight ahead. That's the point. Romeo India 405. Turn right. Romeo India 405. It's a waypoint. It's just a point on the map. Turn right. That's correct. After Romeo India, turn right. At maximum 185 knots. Okay. You would have a speed restriction here. That's here. during the turn to Romeo India 406. At Romeo India 406, turn right to Romeo India 407. Correct. Right, the Romeo India 407. Climbing to 6,000 feet or above. Romeo India 407, 6,000 feet. At Romeo India 407, turn right to ear ducts at 8,000 feet and hold. So you would go to this waypoint ear ducts, and there you would stay in a holding to set up the new approach. Okay. It's a lot of information that has to be in there. You wouldn't have, of course, if you have to fly this, you wouldn't have to look at the chart because the flight director knows the way. Okay, you just can fly pretty much anything with the use of the flight director. Exactly. Yeah.
And the flight director will do also this turning.
Exactly. Yeah.
The autopilot.
The autopilot. You could do it manually. The autopilot also does nothing else but following the flight director. It does it, of course, very, very precise in comparison to any human. Even seasoned pilots won't fly it as exactly as the autopilot can. It's natural, of course. But yeah, you just have to tell the flight director where to get the data from. At the moment, the flight director pulls the data from the route that's planned into here. Yeah. So the flight director pulls the data from this magenta line.
Yeah.
Should you have to navigate manually for a reason, and should you have to select a different course, you would have to dial it in here. Let's say the controller tells us turn left to heading 170. Of course, the plane doesn't do anything because it wants to follow the route. If you push here, heading select, push it. The flight director pulls the data from this line here. Okay, so the flight director, if you want to disconnect the autopilot, 2 times. Yeah, exactly. And now the flight director takes the info from whatever I dial in here. Now it says go to the right. If I want you to follow the route again, I push LNAV, and now it takes. Don't think. It takes the input from the route again. Okay? So there are several autopilot modes for pretty much every possible situation.
Okay. If I want to engage the autopilot again, I press here.
Yep, exactly.
Or here.
No, that's just a disconnect. To connect it, you press here. Exactly. Yeah. And that's the how it works. And you can get pretty creative with the autopilot modes in terms of what you want to achieve. Yeah, it depends on certain factors, but that's the whole autopilot interface.
There was a turn here.
Yeah, because it realigned itself. It realigned itself with the track, and there's another turn. It was just for demonstration that you can now that it follows the route again. You can dial in whatever you want here. The plane doesn't listen. Why doesn't it listen? Because it wants to fly the route. If you put it here, then this is effective.
Synthetic 737, descent flight level 180, normal rate.
Descending flight level 180. Okay, he wants us to descend already because we're relatively high. Flight level 180. That's 18,000 feet. And he wants us to descend at a rate of about 2,000 feet per minute. The plane wants to choose the descent rate now by itself, but that's something we don't want. We want to tell it, please descend at 2,000 feet per minute. So activate this mode and use the dial to go to minus 2,000.
Okay.
In the automatics mode, the plane tries to calculate the route by itself, but under certain circumstances you want to follow it certain values that you tell it. So those are the manual modes, those are the automatic modes.
Okay. That's the maximum speed?
No, not maximum. It's just a good speed, so that we can slow down afterwards in the right time.
How long is the training for this plane?
Training, if you do it, pretty much for any plane. If you're a pilot, then for a certain, you're only allowed to fly one certain type of course because they're all handled differently. It's about half a year of training.
Synthetic 737 conduct Polar radar 124.6 job.
1246. But you would of course be already a pilot, but for this certain type you would only have a few months of training. Polar radar Synthetic 737, flight level 255, descending flight level 180 at 2000 feet per minute.
Synthetic 737 Polar radar identified, continued descent flight level 90 after passing gear maintain heading.
Down flight level 90 after gear maintaining heading. Okay, that's a different, that's an interesting order now. That would be our route, okay? But we are not allowed to follow it because we are a little bit high, so he probably wants to turn us in this way. After Girda, so first of all, descend to 9,000 feet. And then he said, after Girda...
Vectors ILS runway 14.
Vectors ILS runway 4. After Girda, maintain heading. Okay. At the current mode, the plane would turn left before Girda. If we want to stay on that heading, we have to tell it manually. So you take heading select. This mode is deactivated, this one is activated, and we fly. After Girda, we stay on the current heading. Okay? So it won't take the turn here. Would we have left it in LNAV? We would have taken the turn, but we want to select our heading ourselves, and that's the idea behind it.
Is telling us that we are selecting another route different of the one that was
no, this always tells you the current route that is programmed. You won't see any changes you do up here, but this is the actual route how we programmed it. You can also delete certain points, you can add certain points. For example, if I want to add a waypoint, we have let's say there's a waypoint Victor Papa 054. If I want to take this into my route, Victor Papa 054, after Girda, if I want to go there after Girda, I put it after Girda. You see? And then you can actually, it's just armed, it's not active. I can activate this then. And then it's in the system, you see? That's how you add it.
But then you jump from here to here.
Exactly, if it was just for demonstration, I can also delete it again. And then I can connect those two again, because the plane says, are you sure what you're doing? So I would have to connect those. And everything's fine again. Also, so that we won't forget, set the automatic brake for landing, set it to 2. That should be enough. So as soon as the plane sits on the runway, it would also brake automatically.
We did the check-in already for the...
the descent checks, we would do that in a few minutes, and the landing checklist then again is done on the immediately before touchdown.
Okay. What is this hook here?
That's the landing gear. It has 3 positions. Of course, down. After takeoff, you select it to up. And in order to relieve the pressure of the lines, you would have to select it off, because otherwise you could lose hydraulic fluid or something like that. So you have you also have an off position. In modern airliners, you only have up and down because the plane knows when to depressurize the system by itself. But this is an analog control, and so it had to have 3. And it's interesting because those elements always have the shape of the actual elements you want to move. So this is shaped like a wheel, a gear. This is shaped like a wing profile, the flaps. And so that's because I think it was in World War II when the knobs and levers all were the same, and people often would mistake them for something different, and so they said, okay, let's make it like the actual physical element it's supposed to move.
Synthetic 737, turn right heading 280.
Right, 280. Yeah. Okay. Exactly. so we are now not following the route, but the orders or that the controller gives us.
This is another compass.
This is another backup compass, exactly, yeah. Below 10,000 feet, we are not to go any faster than 250 knots, so dial the speed back to 250, and we would have to observe if we're actually slowing down. Yeah? Probably not enough. So we wait until 11,000 feet, and if we are still too fast, we'll use the speed brakes to slow the plane down. Okay. Those are those elements on the top of the wing which can be raised in order to produce more drag.
The spoilers, huh?
Spoilers, exactly, yeah. Yeah, okay, it won't work, so we use those. Pull that lever up and then pull it back, and then you can observe how the speed rapidly drops, okay? You also hear the wind noise, and now you see the trend vector for the speed going down, and as soon as we have the 250, just pull it forward into the lock again, okay?
Synthetic 737, turn right heading 350, descend 7000, QNH 1022.
Right 350, 7000, 1022. First of all, right 350.
Right,
heading 350, yeah. Then 7,000 feet on the altitude. 7,000. And QNH, the new barometric pressure, is 1023, but you are busy at the moment, so I copy it over, and that's it. Okay, we are reaching the speed, just push it forward. It's also called the lever of shame, because it normally, if you have to use it, it's a sign of poor energy management, because you try, of course, to do it as smoothly and as efficiently as you can, but under certain circumstances it's necessary to...
Yeah, this is waste of your resources.
It burns, actually, it bleeds off the energy, and the idea is to do it in one go, not to have any steps in there, but to go in one smooth descent rate, but sometimes it's not really possible. The lever of shame, yeah.
It's only one, no?
It's only one, yeah. That's the only lever that induces shame. The other ones are all glorious levers. And that's, you see, if you go to the plan mode, you can actually see where we are and where our route was supposed to be. So we didn't follow it there. He led us out there, and now he's turning us around back to Girda, I suppose. He will bring us back to Girda. So this turn was just to lose a little bit of altitude. So that's actually the weather radar. So that is actually rain, clouds with rain in them. Yeah?
That's actual
should be those towers. Pardon?
That's actual conditions?
Yeah. Okay. That's the actual conditions. And I think that's those clouds over there. I think this one is the one over there. Yeah.
Synthetic 737, contact Rijeka, approach 127675.
127675. Rijeka approach Synthetic 737, passing 8,000 feet, descending 7,000.
What is this thing?
Synthetic 737, Rijeka approach identified. Proceed direct Girda and follow ILS. Zulu approach runway 14.
Proceeding direct Girda, following ILS, Zulu approach runway 14. Okay, now we have to go directly to Girda. I punch it in. Girda. Over there.
Girda.
Okay, thank you. Yeah, Girda. And in order to follow it, push execute. Of course it doesn't do anything because we still are in heading select, go LNAV, and now it turns itself towards the Girda waypoint. You can reduce the speed to 210 now.
With this? Why so slow? Why 210?
That's just experience. That's something you learn the longer you do it. You know exactly when to start reducing the speed, because you know how the plane handles, how long it takes to decelerate, but you rarely have any are given any orders in terms of the speed. At busy airports, of course you have to maintain a relatively high speed until relatively short before landing, but in this area it's not a problem. You can pretty much fly any speed you want. Okay, check the frequencies again. 1085, 1085, 1085, 140 on the course, 140 on the course.
105.
Yeah, I just checked it so that, those are for communication, those are for navigation.
Okay.
Com, nav.
Okay.
I just like to check the frequency, but because it happened that I dialed the wrong frequency in, and then everything's not that great.
And there are two.
Yeah, for two sets for each pilot, a second set, one set exactly.
And the values are different. Which one is being followed?
Which one is? No, they are not different at all actually. But you can switch. Which I could also, if you would have another frequency, and I want to have to display it on mine, I could select yours. You can change which of the two navigation frequencies you want to have shown. So it's not that you can only see yours. You can also see VOR2. That's on my side. So you could switch that to 2, and then you would have the same. In this case, it doesn't make a difference because we have both the same frequencies. But certain procedures require me having another nav 8 than you, and then you would have to switch it because at a certain phase you might want to see the one I have on my side. Okay.
This is 2 position?
Yeah, three position actually. Off, VOR and ADF, which is another kind of navigation icon. Beacon.
And we are in 4. This is
VOR2, that's mine. That would be actually this one.
In ADF?
ADF1, ADF is this one. That's another, that's the ADF, okay? That's a different kind of navigation beacon, rarely used these days. NDBs they are called. They don't give you that much information. It's just an arrow pointing in a direction. It doesn't give you any distance information. So that's also something from the 60s and 70s. These days it's rarely used.
Why is this hole here? Because the thing.
Yeah, exactly. So that it can go in there. Okay, that's the. Rijeka Pro Synthetic 737, I think I didn't get if we already got another descent from you.
Yeah, Synthetic 737 descent 5,000.
5,000 feet, okay. The plane wants to hold the altitude, so you would have to confirm that we want to descend, push this one again, and then go to minus 1,000. No, minus, down, exactly. Yeah.
What is this? Yes.
Vertical speed. You tell the plane to fly a certain vertical speed. So that's not the speed, the horizontal speed. That's the speed. How many feet per minute you want to lose in altitude? And you see,
it goes 1,000 per minute. And I can change it while this is engaged.
Yeah.
So I can.
If you go to 800, you see the nose coming up. Exactly.
Okay. So actually, the main controllers are this one.
That's the interface to the autopilot. Exactly. Yeah, you can, depending on the situation, you can choose a lot of combinations, and that's actually the most. How should I say, the most complex part of the whole airplane, understanding how every mode ties into another one and how it ties into the systems. And that's the speed. You see this yellow arrow here? Turn it to 1. Turn it back to 1.
To 100?
Yeah, no, to 1. What do you want? There's a little 1, a green 1 on yours too. And that's the speed for the current flap setting, so that you don't overstress the flaps. That's the current correct speed for the setting flaps 1. So I put out the first stage of flaps. We can...
Synthetic 737 continue descent 3,400. Already cleared ILS runway 14.
Cleared ILS runway 14. 3,400. 400. Exactly. Now push this one so it looks for the beacon signal. Exactly.
Okay.
It's white, which means it's not active. It's armed, but not active. And as soon this goes to green, we are on the lead in on the correct course. Flaps 5. Match the speed to the little 5. Perfect. And you can already we already high. Put down the gear, pull it, and down. Yeah, landing gear down. Flaps 15. Okay. And as soon as we see out of the clouds, you can actually deactivate the autopilot and fly the approach manually. Okay. Just concentrate on the. You can actually do it already. Just concentrate on the. Yeah. Disconnect it first, 2 times.
Yeah.
2 times. Yeah. Exactly. And down, 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 down. We have to go down. Exactly. Yeah. No more. Keep it like that. Not more, not more. Follow the flight director. No. Yeah, exactly. Yeah, great. Okay, great. Now follow the. Yeah. A little corrective inputs, down the nose, a little down, onto the flight director. Yeah. Now pull it up. You want to have this diamond always on this line in the middle.
Okay.
Okay. If you fly the flight director, then this is always the correct. Oh, not that much, not that much. Wait a minute. Okay, come.
No, I have no line.
Yeah. For some reason it's... Put it down, put it down, put it down. Okay. Okay. Actually, you know what? Because that works pretty good, we do it without the flight director, just looking outside. Do you see the white light ahead of us?
Yeah.
Okay. Aim for it. To the left, and down with the nose. Put down the nose, put down the nose.
And to the left, then there's another light.
The runway is right of the light, okay? Nose up, nose up, nose up. Not that much. Pull it up, put it a little bit to the left. That's great. Aim for the light. Try to have the light on the same position in the windshield, okay? Now down again the nose, put it down a little bit.
I think we're talking about different lights.
No, I don't.
Synthetic 737 contact Rijeka Tower 119.0.
You will see it in a minute. 119.0. Rijeka Tower, Synthetic 737, established ILS 14. Now a little bit to the right.
Synthetic 737 Rijeka Tower, good day. Winds 110 degrees, 4 knots, runway 14, clear to land.
Clear to land, runway 14. Now to the left again. Exactly. Straighten the plane, straighten it, straighten it. Wings level, nose up. There's a white and a red light, okay?
White and red light. Yeah.
To the left, exactly. If you see only red, then you are too low. You have to go up.
Okay.
For red, you are dead, okay? It should be too white and too red. So keep the wings level, okay? Now a little bit to the left because we are far a little bit too much to the right. Nose up a little bit. As soon as we see another white light, we can go on with the descent, okay? Okay, keep it like that. Drop the nose a little bit. Yeah, drop it a little bit. We wait for the light. Now to the right a little bit. We have to aim for the runway. Nose up a little bit. Straighten the plane. Nose up a little bit. Okay, that looks good.
I see the runway now.
Yeah, genau.
But
now
it's still red.
We have to fly level for a little bit, but then it goes rather quickly as soon as the white light. See it? Okay, let it drop a little bit. That's great. A little bit to the left. Yeah, nose down a little bit, a little more. Try to keep the runway in the middle of the windscreen, or at the same position. That looks good. A little bit more down even. Push it down, push it down, push it down. Now don't. Yeah. Keep the wings level, okay? You can't do corrective actions, but you would have to level them again. Pull a little bit, pull a little bit. That looks good, actually. Check, that looks good. 1000 is checked. A little bit to the left, nose a little bit up, and just smoothly glide in like this. Don't do any heavy corrections, sudden corrections. To the right a little bit, nose a little bit down again. Down a little bit the nose. Nose down, nose down. A little bit to the left. A little bit to the left. Good. Even more a little bit. Nose up. Wings level. Level. Yeah, exactly. Oh, that's good. Yeah, a little bit down the nose. Down. Wings level. Down. Yeah, okay. And now just slide in there. A little bit down the nose. The nose a little bit down. Enough, enough, enough. Keep it like that. Keep it like that. And if I tell you, then pull the nose a little bit up. That looks good. A little to the right. Enough. Straighten it. Now ease on the nose. Pull it up a little bit. Pull it a little bit up. Keep it. Keep it. Let it drop. Let it drop. Like this. Just like this. No sudden corrections. Now nose up a little bit. Yeah, oh, and put it forward. Oh, that was a great one. That was a good one. With the pedals, keep it on the center line. No, no, no. Just with the pedals. That was pretty good, actually.
Okay.
That was pretty good. Okay. It's actually raining, you see.
Yeah. I didn't feel the ground.
Yeah, of course. That's not really. Take the.
Yeah.
Okay. Good. Easy, easy. You've done it already, and it was pretty good. It was really pretty good. It was a very soft landing. Take the throttle control, and there's a turning pad.
Welcome at Rijeka. Backtrack 14 is approved. Congratulations, Tiger check.
Backtrack approved. Thank you. Okay. To the right, and then turn it in. Okay. With
to the right, and full turn.
Easy, easy, easy. The same as before. Don't stress yourself. Now to the left, okay? Das war ziemlich gut. Das war ziemlich gut eigentlich, ja. Entschuldigung. Okay, throttles in. It's a little much. Yeah, exactly. And now follow the runway and we'll take the first exit. So, now I'll do my stuff. Ja, das ist, wenn es regnet, das ist total super da. Haben wir lang schon immer gehabt.
Synthetic737, next exit, right where Bravo stand for.
Right where Bravo stand for. Das war spitze. Good, good, good.
You turn it off tough.
Exactly, that's now my flow as a co-pilot, so I start the APU, that we have electricity afterwards. I'm turning off various systems we don't need any longer, so you can concentrate on taxiing in.
Okay.
Throttles on idle. Yeah. Okay. Just go a little bit to the left so we can take the exit smoothly. Okay, and this one, we take this one, and then we'll pass the Lufthansa Airbus, and after that we'll turn to the. Okay, great.
Much.
Yeah. Okay, we follow this one. Ohne sterben, ja.
After the Lufthansa flight.
Yeah, exactly. We'll after this one, so follow the line on the ground. And you would have to turn in on a very steep angle. You see, it goes to the right. Just stay on this on the line.
On the line, on the yellow line.
And when I tell you, then you turn it to the right.
Okay.
Speed is good like this. So that's 3. And there's our stand 4. Wait a minute. No, still don't. Still not, because the wheel is so the nose wheel is so far back. Now turn it to the right. Keep it. Because what you have to take into account, that our steering wheel is like 2 meters behind of us. Okay, and that makes it totally different. A little bit of thrust. Yeah. Keep it like this. Keep it like this. Thrust away. Kill the thrust a little bit more to the right. Yeah. Still a little bit more. Keep it like this. Keep it like this. Keep it like this. And braking. Okay. Okay. Then we turn it off. Now comes the. It's not like in a car with just pulling the key. Good, okay. I already started the auxiliary power unit. Turn off the 3 white lights. Yeah, you can see actually the lights actually turned off. Now you can kill the engines, one after another. One after another, okay? Okay. Then we wait for the engines to spool down. And as soon as we are about 4%, we can switch the strobe lights off, so everybody outside would know that it's safe to go near the approach the airplane. Okay, switch it to off, anti-collision. Yeah, that's the those not. Those are the red light on the top and on the bottom. They blink. Those are the ones in the wings, the green and the red one. Those are switched on as long as the aircraft has electrical power. Okay. If you're on an airport, next time just look at the plane, and if the wing lights, red and green, are switched on, then there is somebody in the airplane and the airplane has electricity. As soon as the lights start flashing on top of the bottom, then you know that the engines are going to be started within the next 1 minute or so. Okay. Those one off, those off. Yeah.
What is this?
That's the air conditioning. Yeah. Also this one.
And what are these ones, right?
Those are the hydraulic pumps. You can switch those off. Those are actually bleed air valves. They take, if they are open, they take air from the engines and feed it into the air conditioning. Because all the air in the airplane actually comes from a high degree of the warm air is actually directly tapped from the engine. Air is tapped out. Those are the valves. Of course, you would have to also be able to close them. If you open them, then the air goes into the air conditioning pack, is prepared, and is then fed into the cabin. That's how this system works.
That's why sometimes it smells like fuel in the.
That's the reason why you sometimes can smell a slight smell of fuel, because it is actually, it's also the aerotoxic syndrome. I know if you heard about that, that sometimes people can get sick. It's a little bit different with modern planes. In the Boeing 787, it's all done electrically. So the compressors are driven electrically and not by the engines, which is a good idea, of course. Window heats, those two and those two, you can switch those off. Yeah. Then the galley power.
What is galley?
The coffee machine and all the stuff. Fuel pumps, all 4 off. Yeah. Yaw damper off. The navigation systems off.
So bye-bye.
Then the emergency exit lights off. Genau. And the APU off. And the battery off.
The battery.
Open the cover and yeah, exactly. Great. It was actually a pretty solid performance. To be honest, it was really good, because you
say that to everybody.
No, I don't say that to everybody. Of course, I try to be positive, but it's not that long ago that somebody just didn't really get the.
Ja, check. He do.
Bitte? Ja, okay, natürlich sage ich es. No, I don't. I try to be positive, but there are of course differences. And the first thing when I notice if this is going to work, is doing the briefing. If somebody gets this right, it's a good sign, but not 100%. If I see somebody doing this and having a little bit of feeling in their fingers, then I know there's a good chance that the flight would end well, because most people can't really handle this. They do like this and do like this and do like this, and you pretty much got it that you can do slight corrections in between. And the ILS approach is when it all comes up, because you did it by yourself. Of course, there's good landing, there's a lot of worse landings. Sometimes landings are even better, but that's up to, that also can be of course a little random, but it was a pretty good landing. You might have noticed it by yourself, because it wasn't something like this. It was a very slow and continuous movement, and that's the idea behind it. As soon as you start working like driving a tractor like this, then you're doomed. Okay, you really would have to slowly give the inputs, and that's what you really did. Of course, we were a little bit left of the center line, but that's the fine craft and art of the whole thing. But other than that, it was a really good performance. Okay.
Okay. How would you use this? You fly without the seatbelt?
Yeah, normally, but since this doesn't move, you don't really have to.
And you told me it's a 5-pound thing, so.
It's actually these two. Then you would have to, even from down below, there's another one.